All right. Hello, everyone. Welcome to one of the last sessions of the day. My name is Matt Roman. I lead product and technical marketing for Celestica. I'm super excited to be here with Mark Austin, co-founder and CEO of Hedgehog, and Florian Berthold, customer. He is the principal software engineer at Zipline. So thanks, guys, for joining us, and thanks, everyone, for attending. So we'll just jump right into it. We'll try to keep this interactive amongst us, and hopefully you guys will find this informative. So let's start off with you, Mark. Celestica and Hedgehog have been collaborating on a number of really interesting opportunities. But before we kind of dive into that, just tell us a little bit about Hedgehog.
Sure. Thanks, Matt. So, hi, I'm Mark. I'm co-founder, CEO of Hedgehog. So we are open source software for your AI network. So we work with Celestica hardware, and our combined solution enables people like Florian to deploy AI infrastructure.
Thanks, Mark.
And I'm Florian Berthold. I'm a software engineer at Zipline. I am responsible for our on-prem infrastructure. I deployed it, I maintain it, and I'm a happy customer of both Hedgehog and Celestica. And our company, Zipline, is a logistics company. We've been deploying healthcare and blood products in Rwanda for over 10 years. You might have heard about us. And we recently launched our doorstep deliveries in Arkansas and Dallas this year. And it's huge success so far.
Awesome. Thank you. And let me just make a few comments about Celestica. So for those of you that don't know Celestica, we're headquartered in Toronto. We're about a $10 billion technology company. We do product design, product manufacturing globally. We also design and sell our own products and bring our products to market. Our success as of late is really fueled by developing and manufacturing AI-related technologies for hyperscalers. It's really what's fueling our growth. And the part of the business that I'm focused on is bringing Celestica branded products and technologies, including networking hardware, networking operating systems, storage systems, compute, as well as providing services. And when we go to market through channel partners and also selling direct to end users. So that's a little about the three of us. So let's jump into a little bit more of the meat of the discussion. So Florian, if you could tell us a bit more about a couple of the interesting use cases where Zipline technology is deployed.
Yeah, of course. So our drones making these deliveries leverage onboard inferencing. One of the use cases, for example, in the airspace, we need to be able to detect and also avoid other aircrafts in the area. We also use inferencing and kind of image recognition and semantic segmentation to figure out the right spots to do the delivery. So it needs to be even, but that's not enough because having your burrito delivered into a pool is not the right experience we're looking for. So it really needs to make sure there's no docks, there's no slated angles, surfaces, and that's where we do our deliveries. And that's our embedded use case. We also use AI in a few other areas. One of them is, for example, we use live weather image data from geosynchronous satellites to figure out cold weather fronts to make sure that our drones, especially the long-range delivery ones that fly in Rwanda, avoid these high wind, high turbulence areas and steer around them.
And we were talking earlier, you had mentioned one of the biggest challenges, especially in the metro areas, is power lines, which I don't necessarily think of, but
correct.
Could be pretty catastrophic for
it is,
a drone.
But it's to our advantage. These are very well documented. So each power line US is listed somewhere. And when we roll out to new areas, we have access to all of the data. And of course, this is a crucial part of information, whether or not this is deliverable site or not. You don't want to have delivery right into power, of course.
And for either of the examples, like what's the size of the payload? Take anything from a retailer? Or?
So our partner, Walmart, you can order more or less anything that fits into our zip. The weight limit is over the time will be increased more and more. You can deliver like everything from a bottle of Coke to I don't know, ready to eat burritos and stuff like that. It's really a versatile solution. We have other partners, Buffalo Wings, for example, where you can get your steaming hot wings right at your doorstep within minutes.
And you had shared a specific delivery time, which I thought was pretty impressive.
Yeah, it's like we have really fast delivery times below 10-minute mark, and those wings will be so hot that you have to watch out. Caution, content is hot.
So this means that, like, if I'm watching the Dallas Cowboys on TV on Sunday and I see the Buffalo Wild Wings commercial, I can order through Zipline and have those Wild Wings
after the break.
That's pretty amazing.
Mark, you had shared another interesting use case around military battlefield. Can you talk a little bit more about that?
Yeah, this isn't the first time that we've been on stage together, so people have kind of heard about Zipline and our role with the infrastructure. So, the military is always looking for dual defense use cases, dual use defense. And, this is a great example, right? If I have, drones that are delivering medical supplies and blood products in sub-Saharan Africa and remote locations, surely they can do that on the battlefield. If Zipline's developed, an airspace management solution that enables drones to navigate autonomously, to go pick up a payload, navigate to the drop-off point, drop that payload, in sometimes difficult landing zones. You ought to be able to manage airspace for autonomous combat vehicles and manned combat vehicles and all the other things that are going on in that airspace. So yeah, we've gotten inquiries for that kind of use case as well.
Mark, Hedgehog uses the tagline, network like a hyperscaler. Can you explain to the audience what that means from your perspective?
Yeah. I'm going to let Florian chime in on this because they're the hyperscaler. But the network like a hyperscaler, it's a blueprint. It's to do the same thing that Amazon, Microsoft, Google, or Oracle do to build hyperscale data centers that scale compute storage resources elastically, and do it cost effectively, as a service. And so, that starts with working with hardware partners like Celestica on joint designs for hyperscale data center equipment, network switches and storage, and compute. So doing that through the Open Compute project. And then from there, it's using open source software. So we started with Sonic, which is an open source network operating system. It was started by Microsoft and Meta. And then what we did is we built a software appliance around that operating system that fully automates the installation, configuration, and operation of that AI cloud network. And when you fully automate all of your operations and you do it with open source software and you have a really good supply chain from great hardware partners like Celestica, you're able to scale your infrastructure to meet the hyperscale needs of the business.
Yeah.
How about the hyperscale needs of the business? What are those?
So, we're a huge hyperscaler. But you got it on point. It's about making sure that you're able to scale quickly without drastically putting a lot of human resources into the mix. So using standardized equipment and abstracting away all these complicated network configuration things behind some service like Hedgehog, where I, as a software developer, I don't know anything about the Sonic operating system, how to configure an ASIC and how to tell it how to route from A to B. I speak Kubernetes, for example, and that's how I got access to all of it. So I can now declare the wiring scheme, I can declare the routing, the VLANs, everything, tell Hedgehog how to do it, and it rolls it out to my switches. And it has never been easier to run your own on-prem data center. I think cloud providers want you to believe it's hard, it's difficult and tricky. for certain use cases, it's really like the software that's out there available for doing your bare metal provisioning, for running your networks, and for like all the services that run on top of it. There's a huge amount of open source and amazing commercial opportunities out there to do that for you.
Can you give everybody an idea of like the number of deliveries you've done to date and miles flown and sort of what you're doing currently to deploy Dallas Fort Worth? Like, it's pretty astounding, really.
So I know roughly the numbers for our long range deliveries. I think we've flown 1.5 million deliveries so far, and I think I don't want to speculate, above 100 million miles flown altogether, and all autonomous. So all of these drones, none of them is like human operated. No one is driving anything here. It's really the drones themselves from takeoff all the way to the delivery and flying back are fully autonomously operated. And our P2 drones, the doorstep delivery drones that we launched in Arkansas and Texas, have like really amazing growth, and we have hundreds of deliveries.
And Florin, you mentioned management and provisioning, and not knowing the bowels of networking infrastructure. I guess aside from the management and provisioning, why didn't you go with a traditional public cloud solution or a traditional networking supplier beyond the operational pieces of it?
So as I mentioned, running it yourself, once you crack figuring out how to run it yourself, the opportunities that you have is you have governmance over data and all the jobs, the use cases that run on your own infrastructure. That's important for us. Another huge factor is cost. The cost benefits are immense. You have 75-80% cost reduction of owning your own hardware and operating yourself compared to like a 3-year lease on a cloud vendor. And in case of networking, it's again, cost is a huge difference. Like there's a order of magnitude in fees difference between using a solution like Hedgehog and something from a legacy provider that just tries to squeeze you in, lock you in, and then threatens you with 5-year end of life cycles where you need to purchase new hardware. And I don't have any interest in collaborating in these kind of schemes.
Thanks. Can you talk a little bit more about sort of the technology, GPU compute, maybe both in the drones as well as sort of what's in the back end that's running sort of AI and the modeling?
Yeah. So technically speaking, we have 3 compute units in our doorstep delivery drones. We use them to run local inferencing for camera data, both as mentioned for surrounding airspace and as well as small SIP that we lower down to actually do the doorstep delivery. There's also kind of live real-time inferencing that helps us to figure out, okay, what is a landable area? Where can we deploy things? I also mentioned inferencing that happens based on weather data that runs in the kind of real server hardware, and that's all for operations. And of course, we also have R&D. So we have servers, GPU servers, where we run the model training. We have like big, huge models that we use for ground truth data generation, and we have then also the small, hyper-optimized ones that have to run on a drone that is flying with battery power that has to share the power with the compute with motors. It has to actually have enough power to do delivery. So that's quite a challenge to making sure that we don't kind of stress too much the compute and the energy requirements for running. So it needs to be highly optimized. And the GPU on-prem server farms that we have kind of enable us to do all of this in a cost-effective way.
Got it. Thank you. Mark, it might even be a tagline on your website. It's your solution is for cloud builders who grew up with AWS. So how do you address this? How do you enable people to have multi-tenancy, multi-cloud? What's your solution? What's the uniqueness of what Hedgehog does in this area?
Yeah, I guess my first question, I'll have Florian again help me answer it, but Before you started running your own infrastructure, were you running workloads on AWS?
Oh, yes, of course.
Yeah. So I think that's the default assumption, right? Most people get started running their workloads on public cloud. It's fast. The lower to entry is very, very low, and it works great. And then at some point in time, you sort of reach a point of scale where you need to run your own infrastructure. And then the question becomes, do I have, the competency, the skills, the people, to run my own infrastructure? So, I guess my next question for you, Florian, is are you a network engineer?
No, absolutely not. No, I'm a software engineer.
Okay. And so how would you describe like your skill set and skill set of your team when you sort of got started at running your own infrastructure, and sort of what's changed since then?
Just to get a little bit more technical, the challenges that you have when running your on-prem data center is, it's different than your home lab. You don't have just a single switch in the corner that, has like layer 2 connectivity to all devices in the home. You need to introduce things like spine leaf topologies, right? You want to scale out, have, high availability, fault tolerance. You need hundreds of gigabits of, connectivity, and configuring all of this is non-trivial. It's a highly complex, collaboration of your host setup. You need to have the right transceivers. You need to have, the right switch operating system and firmware. And I have no idea how any of this works. I'm not an, I don't know, CISC, whatever, certified CIE network engineer. None of that. So I don't know how to operate the network CLI of NOS. And this is really where Hedgehog kind of jumps in and takes this whole away and abstracts it into a language that I can understand. So I do DevOps. I operate Kubernetes clusters. I know what GitOps does. As we heard in the previous talk about deploying my specifications, and now I have a way to write these specifications and say, okay, this switch or this server is attached to this port and is part of VLAN 500, and that's it. That's kind of my way to specify these configurations. And I don't have to go in and make sure that the switch has all the best practices applied and is tuned. This is all abstracted away.
Yeah. So your GitOps process for your private AI infrastructure, is it more or less the same as your GitOps process for workloads that are running on AWS?
More or less the same. Like it's the same technology stack. You have different operators or providers kind of in between that do the translation from different technologies to each other, but it's the same approach. Like I don't have to SSH to a switch. That's not another thing for me anymore.
Right. Yeah. So to answer your question, like our job is to make it possible for everybody to run their own AI infrastructure with the same people, same process, same tools, same skills that they already have for running workloads on public cloud. And the way we do that is by just simplifying the process of designing, building, and operating your own infrastructure. So if you look on the screen behind me, there's sort of a logical view of GPU AI infrastructure that Florian's running. There's some dotted lines there that represent links that connect servers to switches, and we automate the process of configuring all of that stuff together with your hardware. And then we present a cloud native user experience to a DevOps user like Florian. And we do that with a cloud native API that delivers a cloud-like user experience. And the goal is to make that on-prem infrastructure look, feel, and operate like public cloud infrastructure. And hopefully we're doing a reasonably good job of that.
Absolutely. I didn't have to touch them for last couple of weeks. Just works perfect.
Cool.
Excellent. Very good. Actually, a question for both of you guys. Would like to get your insights on how AI at the edge is different than more traditional large scale AI data center or in a hyperscale environment.
Yeah. We hear headlines almost every day about a new AI factory and how many billions of dollars are going into it, how many tens of thousands of GPUs go into it. And those are super cool projects. But I think the thing to keep in mind is that the goal, all of these AI factories that are training new models, is to have models that can then be deployed for inference, right? And that inference is typically happening at the data edge, right? And the best AI applications are applications that have unique sources of data, and that inference is happening very close to the source of that data, with really lightning fast, low latency inference to deliver a very unique customer experience. And I think you guys have almost all of those ingredients.
Exactly. We have battery operated, and I think I touched it before, aircraft in the air that needs to make autonomous decisions. And if we have to rely on certain ML technologies, and the challenges here are really you can't just slap on a gigantic power like source onto the drone anymore. You can't play with cooling. There's just physical limits of what you can do. And making all of this work is a challenge, but something that we have solved, and something that is like the new technology really, really helps us doing it. Like when there's a new SoC released, and then we get double the inference power for only 50% more power consumption. That's a huge gain for us.
But just to put a really fine point on it, your inference happens at an extreme data edge, which is in the drone, right?
Absolutely. Like the camera and the compute where the inference happens is like a foot away from each other. So and the decisions made based on that inference are applied in real. So it's really you can't be more at the edge.
So you what would happen if your drone had to go back to, I don't know, an availability zone in a public cloud to then make a decision on how to navigate or drop a payload? Wouldn't the latency just kind of kill the application in that case?
I mean, if we talk about latency, you already assume you have connection all the time. Like we don't have that. When our drones fly in Rwanda, they're going to be on their own for 30 minutes and they can't ask anyone for help. So it's really fully autonomous. It's no strings attached.
Right. And so then to create that AI model that drives that autonomous drone, you still need an AI data center where you're training the models, right?
Of course, you still have terabytes of data, training data. You still have the need for dozens and hundreds of GPUs to go through that amount of data in a reasonable amount of time. So we still leverage kind of the big beefy GPUs for these use cases.
Yeah, but it's not like you're not training an LLM on all of the content that's on the internet. You've actually got a smaller infrastructure requirement.
Absolutely, and that's something like in the age of LLMs, everyone thinks, oh, you need at least 4,000 H200 to get something done. We don't have these crazy amounts of needs. We're the embedded use case, the model that comes out at the end needs to run on an embedded SoC, so it can't have billions of parameters, right? The training that we use is much more demanding in some scenarios. One of the examples, for example, that we have, because of the size of the model, the training each cycle happens very fast. So the demand for data transfer between the GPUs becomes more and more relevant. We don't have the biggest model, that the weights are not that many, but this happens every couple of milliseconds. So having fast, reliable network is really a key enabler for this.
Excellent. I guess maybe just one last question for you, Florian. So obviously, I'm sure you've got a long roadmap of technology and planning ahead, but I guess so far in the journey, is there any sort of lessons learned, anything you would do differently, whether it's pieces of technology or operationally, or anything you can share with the audience?
Well, that's a good question. So I think I learned most of what I'm doing on my own. There's not really a lot of information out there how hyperscalers work. I mean, unless you work at a hyperscaler, there's no source of information that shows you how to operate a data center. So this was something new for me. I actually don't even know if I would change anything. I don't know where I would find this information today. This is something that's really kind of more of a tribal knowledge in the industry, I think. Knowing that the technology exists, we have Hedgehog for networking, we have Halos for Kubernetes, we have Digital Rebar for bare metal provision. Knowing about these technologies, about these products, is something that took most of the time, like sifting through all the different options that you have, not really knowing what do I need, not really knowing what can they do for me is a bit of a tricky situation. So knowing the right technology stack out there, and what are the important parts, and what are things that sound interesting but are not that relevant, that's something I would like to send back to me 3 years ago.
Excellent. Okay, so that was it for the questions. We did reserve a little bit of time for questions from the audience. I don't know if we're really set up for that AV wise, but if anyone wants to raise a hand and ask a question, we'd be happy to try to field it. Or get that.
So the threshold, can I repeat the question? So what is the threshold when it makes sense for a startup company to switch from a public cloud to maybe an on-prem? Okay. So that's a very interesting question, because in my opinion, cloud providers are really good choice for very early days of startups and companies, because they don't know what they need, right? You have no idea, do I need 1, 10, 100 servers to run my new application? Do I need to have kind of worldwide data center and content distribution networks? This is something that you get really for really cheap from cloud providers, because they have their deployments all over the globe. Once you have dialed in what you need, and once you have found your key resource usage, take it and put it on-prem. Like I won't create 25 data center deployments for this company because it doesn't make a lot of sense. Like, we have identified use cases, like for example ML training. This is something that can that runs 24/7, has those GPUs, and making use of them, utilizing them. They don't need to be spread around the globe, right? For things like I don't know, data upload that needs low latency and high bandwidth. Yeah, of course, push it to your closest S3 endpoint. But from certain size, and especially once you have your use cases dialed in, I think it's very cost effective to consider these kind of transitions to on-prem.
Thank you.
It was a great question. I think about that one all the time, actually. I don't know if there's a crisp, clean answer to it, but there for sure is an inflection point. I think that was a pretty good qualified description of it. There must be more questions.
End of the day.
Everybody just wants happy hour.
Can you, Mark, can you tell us? Oh yeah. Can you tell us something about the future of Hedgehog? Some new features that you're working on?
Oh yeah. Well, look, our job is just to make it easier and easier to run AI infrastructure. And so, one of the things we'll be coming out with is host-based networking, right? So today we make it really easy to get software on the Celestica switches, to configure that. And what we're finding in working with a lot of our AI cloud service provider partners is that to make it easier for them to tune the AI network performance, for things like nickel testing, configuring the NICs in the servers is pretty important as well. So that the network is tuned with the optimal configuration. As you said earlier, unless you've done it before, you don't really know what the secret sauce is in configuring the network for performance. So that's one piece of it, is host-based networking. The other piece of it is our gateway. So we just we did a preview demonstration at Networking Field Day in July, and it'll be released later this month. But it's a gateway that enables you to get data in and out of that GPU cluster, do it in a secure manner, and hopefully make it simpler for you to operate your network end to end with that same cloud native API. And you've kind of got an interim WAN solution that hopefully we're able to upgrade at some point.
I hope so too. Yeah.
Yeah.
I would be remiss to not talk about Celestica and some of the new technologies that we're working on, and I'll highlight two or three. One is a very robust Sonic network operating system roadmap, which is that's the NOS that's running behind the scenes in this, powers most of the Celestica deployment. So a lot of work going on at Sonic, both on the high-end data center side as well as in campus networking. Celestica will be first to market with 100 terabit switching. So if you're familiar with Broadcom's Tomahawk 6 platforms, we'll be first out the door there. We will retain and grow our market leadership. We're currently, shameless plug, number one market share in 800 gig switching. That's because we're early to market. We're going to continue to do that. And then really two other areas of focus are around integrated optical designs to be able to reduce power efficiency, get better signal integrity. And then the last thing, a lot of work around liquid cooling. So alternate cooling solutions, particularly when you're in that 100 terabit capacity.
Yeah. And I will say, like, it's super, super important for us to have a really great hardware part. So for our software to work, we need to be able to test it and operate it on your equipment. And you guys are just really good partners on enabling that. And we super look forward to answer your question, there's a lot of work that we have to do on our roadmap just to keep pace with, all of the innovation that's coming out of Celestica and our hardware partner.
Fantastic. All right. If there's no more questions, I think we'll wrap it up here. I'm going to say thank you, Mark. Thank you, Florian. Fantastic discussion.
Thank you.
Thanks.